We're up and running. Hi, everybody. So we're talking today 11.3 complex number powers. De Moivre made a theorem that talked about, and this is in the book, so you don't got to write it down, but you will for your notes at some point. If Z equals R cis theta, then, I love the if-thens, then Z to the n equals R to the n cis n theta. So let's play around with that a little bit. What if I did something like, as an example, 1 plus I to the 10th power, 1 plus I to the 10th power, so how would you handle something like that? Well, as always, what do we do first? Well, let's draw a little sketch. Let's draw a little sketch. I don't like that one, that little extra piece. Oh, no, not that. That little extra piece is not cool. Let's get rid of it. No, you guys, actually this mic only deals with stuff really close. So you can just say all the disparaging things you want about me and it won't come out. Okay, so this is 1, and this over here is what? Right here, vertical? 1 I, or I, you're right. 1 I. So that means if we do some kind of a resulting Z here, what angle are we talking about? What angle? The Canadian 45, aka pi over 4. Thank you, Jerica. Canadian 45, pi over 4. So, and what about R? Okay, so theta equals pi over 4. What about R? I don't think so. 1. If this is 1 here and this is 1 here, how, pray tell, is that 1? How much? Gammon, loud and proud, square root of 2. So, oh, y'all are fabulous. So our R theta here is square root of 2, comma, pi over 4. What about I? What happened to it? Let's not lose it. Okay, so if you wanted to do by De Moivre's theorem, R to the n would be R to the 10th. So we would have 1 plus I to the 10th equals R, which is the square root of 2 to the 10th, cis 10 theta. So what's the square root of 2 to the 10th? You don't need a calculator for that. You know why? Because you can say this is 2 to what power? 1/2 to what power? 10 cis 10. Oh, we knew theta. Theta was pi over 4. Okay, this is getting better. And that's 2 to the 5th, and that's cis, what's, what's, where am I? Oh, I know. What is this right here? Oh, not that. God. I was trying to circle it. I'm having a rough day, you all. Tell you what. This right here, what does it become? 10 pi over 4, which is the same as what? 5 pi over 2. 5 pi over 2. Let's look at a unit circle-ish over here. Um, so 5 pi over 2. Here's pi, right? And then over here is 4 pi over 2. So where's 5 pi over 2? Straight up, right. Right. 5 pi over 2 is straight up, which, so in disguise, what is it? It's pi over 2, or 90, yeah. So this we can just write as cis pi over 2. It's the same thing, because it's a periodic function. So 2 to the 5th equals what? 32, good. And then we can go, 32 times cosine pi over 2 plus 32 times I sine pi over 2, right? Where'd they get all this garbage? That's the code for cis, right? Cosine theta plus I sine theta. Or I sine theta, okay? Okay? Make sure that you distribute the R to both, cosine and sine. A lot of times people go 32 cosine pi over 2, and then they'll just go plus I sine pi over 2. Don't forget the 32 over here as well. Okay? So then equals what? 32 times 0 with confidence. Whoever said that? 0. You know, you're right, Daniel. Plus 32 times I times 1 with confidence. Thank you. Beautiful. Beautiful. So 1 plus I, quantity to the 10th, equals 0 plus 32i, or just 32i, which is pretty darn cool. I'm liking it a lot. Questions on that? Pretty neat. Wacky old Demoivre was all right. And they did this back in late 1600s. No calculators, no electricity. They didn't even have indoor plumbing back then. Times were tough. That's a good question. I don't know. He said, did they have slide rules in the late 1600s? Probably, but I'll look it up. That's a very good question. When did slide rules start doing their thing? You don't know what a slide rule is? All right, I'm gonna log off here, but man,